Okay, ladies and gentlemen, here we go again. Let's figure out where, hey, there I am. Okay, so we have cosine of negative 15. Now, cosine of negative 15. I know cosine 15, but I don't know that I know cosine negative 15. Well, here's the deal. Is cosine odd or even? The answer, of course, is cosine is even. So what happens to that negative? The answer here is cosine of negative theta equals cosine of theta. So we can just treat it just like cosine of 15 degrees. Now, cosine of 15 degrees, I'm going to go over here and say, wait a minute, cosine of 15 is 30 over 2, which means square root of 1 and just double check me, cosine, yep, that's my plus, cosine of theta. You'll notice it's about the first or second time that I've used this property sheet. But every time I use it, it's only to verify something I should already know. I should not be spending a bunch of time looking at it. If you're spending more time looking at this than I am, you're not ready. Now, what do I put here, plus or minus? Well, let's look at the original. 15 degrees is in the first quadrant, so if it's in the first quadrant, it's going to be positive. So the answer here is going to be positive. Now, I'm kind of dumb because I already know it's 30, so I should have put 30 right in here. Well, what is the cosine of 30 degrees? Cosine of 30 degrees got 1, root 3, 2. So cosine is going to be root 3 over 2. So 1 plus root 3 over 2 all over 2. That's my answer. Yes, you may leave it right there. Over here, I'm not going to do the whole thing, but I say, wait a minute, I got a sine of alpha cosine beta plus cosine alpha sine beta. That is a sum or a difference. So if I'm doing a sum or a difference, I say sine, cosine, cosine, sine with a plus, sine, cosine, cosine, sine with a plus. That's sine alpha plus beta. So alpha plus beta. In this case, sine of pi over 18 plus rats pi over 9, and I'm going to have to find common denominators. It's going to be 3 pi over 18 using common denominators. Sine pi over 6. Pi over 6, of course, is 30 degrees. So now all I got to do is find sine of 30 degrees. All right, and the answer to that, of course, is 1/2. Now, same thing down here. Whoop. So, real quick, alpha, beta, put them in, add them up, common denominators, sine pi over 6. That's 30 degrees. Draw the picture. There it is. Over here, it's another sum and difference property. All right, moving on. If we come over here, in this particular case, remember, anytime you have a root over a regular number, it's the same thing as saying this, so that might be more helpful to you. But I can draw this picture and I can draw this picture. So in this case, cosine is adjacent over hypotenuse. So I have root x and I have 1. I can find the missing side. Over here, tangent, I have 1 over root 3. So if I do this, this is going to be 2. And let's see here, 1 squared equals the square root of x squared. And so that's going to be x, so it's going to be 1 minus x. So 1 minus plus b squared. So in this case, move this across. I got 1 minus x equals b squared. So this is 1 minus x. And from here, I can say, well, this is alpha, this is beta. And so sine of alpha plus beta, and so that's going to be sine alpha cosine beta plus cosine alpha sine beta. Now, I can find the sine of alpha right here. That's 1 minus x over 1 cosine beta root 3 over 2 plus cosine of alpha root x over 1 sine of beta, which is 1 over 2. Little simplification, but basically there's your answer. Okay, now in this case, like, ooh, that's a half angle. That's a half angle. Or a cofunction. No, it's not. That's pi over 2. That's pi. So in this case, I have alpha and I have beta. Sine pi cosine theta. Since that's minus, this is minus cosine pi sine theta. But wait a minute, what is sine of pi? 0, so this whole term goes away. Cosine of pi is -1, so minus -1 of sine theta. 2 negatives make a positive, and it works out. And verifying means we're going to use sum difference. And then in this case, it's just going to be simplify. Okay, half angle identities. I don't know what 195 is. So if I don't know what 195 is, I can figure something else out. Let's see here. 195 times 2 would be 390. Does 390 help me? Yeah, 390 helps me. So if I have sine of 390 over 2, now I know 390 helps me because 360 all the way around plus another 30 degrees. So I got 1 root 3 and 2. At this point, I can say, hey, 1 minus cosine 390 all over 2, and I can do the graph. Okay, moving on down, find the exact value here, and it tells you what quadrant it's in. It's in this quadrant right over here, and it says cosine is this. Now again, we have this mess. Let's change it up. Okay, let's unrationalize it. And if I do that, that means negative 2 over root 13. So the adjacent side is negative 2. The hypotenuse is root 13. And so I got 13 equals 4 plus b squared. So minus 4 minus 4. So b equals 3. A little quadratic formula there, or a little Pythagorean theorem there. And now that I have this, can I find cosine of theta over 2? Cosine theta over 2 is the square root of 1 plus cosine theta all over 2. Well, what is the cosine of theta? There it is. And so I say square root of 1 plus negative 2 over root 13 all over 2. Now again, is it plus or is it minus? Well, let's take a look. What quadrant was this in? Quadrant number 2, therefore meaning the cosine's going to be a negative. Okay, that's 27. Moving on, verify each identity. Okay, well this one, do we have any properties that are just sitting there? The answer is yeah, yes, and no. Can I quickly move the tangent up to the top? Okay, and can I replace this with the property? So we got 2 tan x sine x cosine x equals. So this turns into 2 sine x cosine x times tan x. And well, honestly, it's done now at this point. So what did I use? I used a reciprocal property and I used a double angle property. All right, now with that one, moving on down, this one, 1 minus cosine 2x. Well, let's see here, cosine 2x. I don't know which one I want to use yet. So I'm going to go over here and simplify this. I'm going to make this cosine squared x over sine squared x times 2 cosine squared x. So I just changed the cotangent by using quotient property. Now at this point, you're like, oh, wait a minute, gone. I'm left with 1 over 2 sine squared x. Well, that basically tells me what do I definitely want to do for this guy. Cosine 2x equals 1 minus 2 sine squared x. That's the property. And so now let's just rearrange some shmoo. I get 2 sine squared x equals 1 minus cosine 2x. So this replaces this, 2 sine squared x. So we got simplify, and we have double angle. All right, and so there you go. This is almost as easy. So from there, you can do that one. Next, we're getting down into the product, sum, product. At this point, you're like, well, there's no squares here. There's no properties here. There's nothing I can change to sines and cosines. But you say, wait a minute, it's just two things multiplied. So let's just go down here and say, oh, sine alpha times sine beta. The 4 I just leave out front. And here's alpha, here's beta. So I'm going to go 1/2 parenthesis cosine 2x minus 7x. And then, so sine alpha, sine beta, okay, minus cosine 2x plus 7x. Just like that. Now, 1/2 of 4 is indeed 2, and I get cosine of negative 5x minus cosine of 9x. Now, it says with positive arguments. So if I want that, all I have to ask myself is, hey, is cosine odd or even? The answer is it's even. So what happens to the negative in here? It goes away. So because it's even, that negative goes away. If this were a sign, the negative would go out front. And it's still in parentheses or in brackets if you wish, because you got the 2 out front. Same thing's going to happen over here. This one works in reverse. You simply use this property. Here's alpha, here's beta, and you go to town there, and it's simply put it in the property. So -2 sine of 8a plus 4a all over 2 sine, yeah, because it's cosine, cosine, minus, minus, 8a minus 4a all over 2. So I get -2 sine of, that'd be 12. 12 over 2 is 6a. 8 minus 4 is 4. 4 divided by 2 is 2. Sine 2a. There you go. Ba, 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 ba. Okay. With that, we have find the exact value of the expression here. Well, it's this, except you actually do it with numbers. Now, down here on the bottom, we want to solve each. Well, sine 2 theta. Man, that looks like in class. Well, that's fine. 2 sine theta cosine theta plus 2 cosine theta equals 0. At this point, what's common to both places? 2 cosine, so we got 2 cosine theta. Not equals, times sine theta plus 1 equals 0. So where does cosine theta equal 0? Where does sine theta equal -1? Well, sine theta is going to equal -1 at 270, and cosine equals 0 at 90 and 270. So there we go. All right, and I think that is, yeah, that's the end. So that's the whole 9 yards. I don't know how long it took me to do it, but not an entire class period. And I'm actually writing as I show and talk to you. Now, I didn't do all the problems, but you get the idea, guys. This is how fast you need to begin moving through it. And it all boils down to, do you know your properties? All right, hopefully this is helpful information.